Now let's go ahead and take a look at making predictions. So this is making predictions based off the regression line. So the idea is the regression line is our best model or representation of the observed pattern. So we can use the line to calculate what the y value would be, or use the equation. So we can use the line to calculate predicted y value. So we have two types of predictions we can make. One is interpolation and one is extrapolation. So for interpolation, the x value we are trying to make our prediction at is surrounded by our data. So the x value we are trying to make our prediction at is surrounded by our data. So by this, I mean, if we have a scatter plot, which has data falling between this x value and this x value, if we say wanted to predict what is happening at an x value somewhere between those where there's data all around, then we could take our line and make our prediction of what the y value would be. So we have evidence that the pattern exists at this x value. For extrapolation, the x value we're trying to make our prediction at is away from the rest of the data. The issue here then, so if we have our data and our regression line, if we want to make a prediction, we have data between these values. But let's say we want to make our prediction beyond those values. We're depending on the pattern continuing past our own data. So this is less accurate or has less chance of being accurate because we don't have evidence the pattern continues. So interpolation is reasonable usually, especially if we have a strong correlation, because we have lots of evidence that that pattern exists, at least near that data. Extrapolation, even if we have a strong correlation, we only have evidence that the pattern exists where our data falls. It could be that we have a very strong linear relationship and then all of a sudden it flattens out. So if we don't have the evidence of the pattern, we can't necessarily say, yes, this is what will happen once we go beyond the pattern. So let's do a couple examples. A study was run on the relationship between height and weight of adults. A linear relationship was found. Again, our key word. We have a regression line of y equals negative 370 plus 8.2x, correlation coefficient of r equals 0.76, and data was found ranging from 60 inches to 73 inches. So we have data from 63 inches to 73 inches. So between these values, we have our scatter plot. So if I want to make a prediction for a person who is 67 inches tall, this is somewhere between 63 and 73. So we can use our line to do interpolation within our data set. So this is interpolation. "67 inches is our x, and we are asking for weight. That's essentially our y. So here we can just plug into our equation. We have y equals negative 370 plus 8.2x. But we are using x equals 67, so we will plug that in. So y is negative 370 plus 8.2 times 67. If we do this calculation, we wind up getting, oh, sorry, I just clicked away from the screen. We wind up getting 179.4. So remember, when we are using a mix of addition and multiplication, multiplication comes first. So the very first thing we should do is our 8.2 times our 67. And then we should do negative 370 plus that. So doing that, we get 179.4 pounds. So this is our predicted weight for someone who is 67 pounds, or for someone who is 67 inches tall. Do the same for 78 inches tall. So this is our x is 78, and we're asking what is y. So again, this is, we have our data from 63 to 73. We're asking for something far beyond. So this is extrapolation. We can still do it. This is based, not basted. We can still do this. So we have y equal to negative 370 plus 8.2 times 78. If we do our calculations, we wind up getting 269.6, and this is pounds. So this first one is reasonably likely to be accurate. We had a strong correlation, and it was an interpolation problem. So just a note that since we had a strong correlation, based off our correlation coefficient and interpolation, we could expect our prediction to be somewhat reasonably accurate. Whereas this one, because it's extrapolation, it's less likely to be accurate. So that is making predictions based off of the regression line.